Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 5-3 Part 2 homework solutions on graphing radical functions. In this one, we'll see some of the extra things we can do with graphing radical functions, like making other shapes out of them. For this first problem, we have these two functions below that approximate the velocity of an object dropped from a height of x feet right before it hits the ground on Earth and Mars. Based off of these formulas here, they want to know the velocity of an object dropped from 25 feet right before it hits the ground on Mars. So if we're doing Mars here, we got to do m of 25. So that's 0.6 times e of 25. But now e just does 8 times whatever you plug into it. So this is really 0.6 times 8 times the square root of 25. And I'll bet I could do this one without a calculator. Square root of 25 is 5. 5 times 8 is 40. And then this is basically 60% of 40. So 10% of 40 would be 4. 6 times that is 24. So this would be 24 feet per second. For this problem and the next two after this one, they want us to use radical functions to graph the equation of this parabola. So on all of these, we're basically going to get y by itself and then graph two different radical functions based off of that. So our first step here, we're going to multiply both sides by 4. That'll give me 4x over there. And then I'm going to take the square root of both sides. I have to remember my plus or minus when I do that. So this is going to give me y equals plus or minus the square root of 4x, which I could also turn into 2 radical x if I wanted to. I could actually go either way on this one. So let me write out my parent function for radical x. That's going to be 0, 0, 1, 1, and 4, 2, or at least the parent table here. And then if I have 2 radical x, well, that doesn't do anything to the x's the way I've done this here. But with the y's, since this 2 is outside, we're going to be doing 2 times the y values. So all my x's are staying the same, 0, 1, and 4. And my y's are all getting doubled. So 0 is still 0. Then we have 2 and 4. Let me graph all that out. So that's going to be 0, 0, 1, 2 is right here. And 4, 4 is here. And now to do negative 2 radical x, I just have to reflect these points here over the x-axis. So this point's coming down here to 1, negative 2. This point is now going to be 4, negative 4. And then let me just draw the parabola going through all of those dots. To graph this function, let me start by dividing both sides by 3. Eventually I need to isolate this y. So we have 1/3 x. And then I'm going to take the square root of both sides with a plus and minus thrown in. So we have plus or minus the square root of 1/3 x. Let me write my parent table for the square root function. That's 0, 0, 1, 1, and 4, 2. And then for the square root of 1/3 x, on this one, since I'm multiplying by 1/3 inside, that means I'm multiplying the x values by 3 over 1, the reciprocal. It's opposite of what you think inside. So 3x is the new rule. And then nothing's happening outside the function, so we've got just plain old y. I mean, we do have this minus out here, but we're going to deal with that a little bit differently. So for my x values, I just have to multiply by 3. So 0 is still 0, 1 becomes 3, 4 becomes 12, and then the y values stay the same, so 0, 1, and 2. All right, let's graph all this out. We have 0, 0. We have 3, 1 right here. And over here I've got 12, 2. And then to get negative radical 1/3 x, I'm going to reflect these non-zero points. So this becomes, let's see, 3, negative 1 down here. And this one is going to become 12, negative 2. And then let's just draw the parabola through those 5 points. For this problem, I'm trying to graph this parabola using radicals. Let me start by isolating the y value and square rooting. So I can subtract 2, and I'm going to undo this negative 8 by multiplying by negative 1/8. And then I'll square root both sides. So we have a plus or minus radical all of that stuff. And then let's do the parent table. So we have 0, 0, 1, 1, and 4, 2. And for this new transformed version of this, for the x's, we're subtracting 2 inside. That means I'm shifting 2 to the right. And that's going to happen after I do this vertical or this horizontal stretch and reflection. So we're going to be doing negative 8 over 1 times x because it's opposite of what you expect. And then I also have to add 2 after I do that. All right, and then for the y values, nothing happened outside the function, so those are exactly the same. So 0 is going to become, let's see, negative 8 times 0 plus 2 is 2. Negative 8 times 1 plus 2 is negative 6. Negative 8 times 4 is negative 32, plus 2 is negative 30. And then the y values are still 0, 1, and 2. To fit these x values, I'm going to probably need to go by like 5s or 10s or something big. Let's see what I went by. Looks like I went by 4s. Yeah, that'll work. So we've got 2 comma 0 is right here. We have negative 6 comma 1 is right here. And then negative 30 is over here, comma 2 is right here. There we go. Now to get the negative version of this, I have to reflect these 2 points. So we've got a point down here and another point down here. And then we'll go through and draw the parabola through all of that stuff. So backwards parabola, good times. To graph this circle using radicals, I'm going to isolate the y, get 2 different radical-ish kind of functions, and then graph it on Desmos. So I'll start by subtracting the x squared, and then square rooting both sides. So we have plus or minus radical 9 minus x squared, and to Desmos we go. So let me do y equals square root of 9 minus x squared. So there's that piece. And then I am just going to cut and paste all this and do y equals negative that. And there is our circle. So here's what I just graphed there. We can see here that we have a radius of 3. The x-intercepts are plus or minus 3. And the y-intercepts are also plus or minus 3. To graph this circle with radicals, let me start by isolating the y. So I'll subtract x squared from both sides, and then plus or minus square root both sides here. So we have plus or minus square root of 4 minus x squared. Let me go to Desmos and graph these 2 different functions now. So on Desmos we have y equals sqrt, square root of 4 minus x squared. That gives me a semicircle up top. And let me do y equals negative cut and paste of that. So that gives me my other half of my circle. So this is the circle we just drew. This circle has a radius of 2. The x-intercepts are plus and minus negative 2. And the y-intercepts are also plus and minus negative 2. To graph this circle using radicals, we're going to isolate the y squared. So first let me get y squared by itself, and then I'll take the square root of it. So one thing I can do is subtract, let me subtract the x squared from both sides and then add the y squared to the other side. So we'll have 1 minus x squared equals y squared. And then if I square root both sides, I've got plus or minus the square root of 1 minus x squared. Let me go ahead and graph this on Desmos now. So we have y equals square root of 1 minus x squared. And then that gives me a semicircle. Let me cut and paste that and do y equals a negative version of that. That gives me my other semicircle. So we have a very small circle. This is actually the unit circle. It has a radius of 1. Hi, unit circle. And then we have x-intercepts of positive and negative 1 and y-intercepts of positive and negative 1.